Okay, this is section 11.2. We're back to solving systems of equations, just like we did in the last one, only this time we're doing them a different way. Last time we said there were three methods. The first one we were going to talk about was graphing. We talked about that one last time. You did some graphing. This time we're going to talk about something called substitution. These are the directions for substitution. You can pause it and write these down whenever you're ready to. You need to understand that these directions are long and complicated. However, the actual act of doing it doesn't take any time at all. You want to notice when you look at it, the very first thing, you want to be able to see either an x is equal to or a y is equal to situation or something close to it. Now we have something close to it on the bottom. I could very easily solve this for either x or y. I'm going to choose to solve it for x. So I decided to pick my bottom equation. So that's my x plus y equals 0. That's like the first step. I picked the bottom one, and I have to solve it for one of my letters. I'm going to choose to solve it for x, so I'm going to subtract y from both sides. That gives me x is equal to negative y. Now that I know that, I can use this information and plug it into my first equation. So I can come up here to that and plug this information into that first equation. So now, since I know that x is equal to negative y, instead of me writing x up here, when I rewrite it, I can just write the negative y. So I can say negative y plus 3y equals negative 4. Well, now that I know that, I can go ahead and figure out what y is. This, step 2. Step 3 is solving for y. So negative y plus 3y, that's 2y, equals negative 4. Divide both sides by 2. Y must equal negative 2. Well, now that I know what y is, I can take this information and plug it back into some equation. I choose to plug it back into this one because it makes this easy. So I come back down here and I grab this equation, and this time I leave the x, but instead of writing negative y, I write the negative because it's not the y, and then I write what y really is, which is negative 2. I just plug it into that. And you get that x is equal to a positive 2. Well, now we know what x is, and we know what y is, so we can write our answer now. Our answer is 2, negative 2. This is your answer, because anytime you solve a system of equations, it's just like you did it from graphing. So your answer should always be a point, or no solution, or infinitely many solutions. This is our answer. The x value goes in the x spot, the y value goes in the y spot, just like before. Now I know it's a lot of lines, a lot of this and that, but it's really quick, and it's not hard to do. Let's look at another one. Change that to a 2 this time. Example 2. Y equals 3, and then 2x equals 5y plus, what was that? 7. Just making sure. This problem is a prime candidate for substitution. because they went ahead and solved one of them for you. Not only did they tell you, did they get a letter by itself, but they went ahead and told you what it equaled. So that makes things like tons easier. So now I can just take this information, plug it in here for every place there's a y. So I have 2x equals 5, and instead of me writing the y, I write what y really equals, which is my 3. So 2x has to equal 5 times 3 is 15 plus 7. 2x must equal 22. Divide both sides by 2. X is equal to 11. Now that I know what y equals and what x equals, I can write my answer. If you were going to do this by graphing, you would have had to have graphed y equals 3, which is a horizontal line at 3, and then you would have had to have graphed this thing and figured out where they crossed. That's a lot of work when all you had to do was really just plug it in. So you want to use this when it's easy to use this. It's not always easy, but you want to use it when it's easy to use it. Now, your homework tonight is going to want you to use it no matter what. Just like we had with the quadratic formula, and I told you you had to use the quadratic formula for that section. When they start giving you an option to use stuff, that's when you can take that option. But I need you to understand when you would want to use this option. So if you can pick out what one of the things is equal to, even if it's just equal to another letter, as long as you got one letter by itself, roll with it. Let's look at one more problem. Example number 3 says 2x minus y equals 1 and 2x minus 5y equals negative 1. This one isn't quite as jump out at you as the other ones were. But if I were going to get something by itself, the color I had to use the other day, I think I want to get that y by itself. So I'm going to start working with the top one. 2x minus y equals 1. That way I don't have to do any division. I just got to move stuff to the other side. So I'm going to choose to move my y to the other side and my 1 to this side. So that gives me 2x minus 1 equals a positive y. See what I did there? That was good, right? Didn't show my work. That's how you move through things. So now that I have this, or if it makes you feel better, y equals 2x minus 1. I can take it because I have the y by itself, and I can bring it up to this one and rewrite it. So 2x, I don't know nothing about no x's, so I just go ahead and write the 2x minus 5. Y, I know something about. Y has to be 2x minus 1. So in parentheses, I'm going to put 2x minus 1 equals negative 1. Okay, so that means that 2x, and then I distribute my negative 5 minus 10x plus 5 equals negative 1. 2x and negative 10x is negative 8x plus 5 equals negative 1. Subtract 5 from both sides. Negative 8x equals negative 6. Divide both sides by negative 8. and x is equal to 3 over 4. Oh, we got a fraction. That happens sometimes. I don't like it either, but we have to use it. So once again, now that I've gotten this part, I want to take it back to my easy one to plug into, which is the one that's already solved for y. So that's going to mean that y is equal to 2, and then my parentheses, 3 over 4 minus 1. Well, it is true that they cancel out, and you get y equals 3 over 2 minus 1. And I happen to know that 3 over 2 is really 1.5. Which just means that y is equal to that 0.5 or that 1/2, however you want to put it. I'm choosing to put it as 1/2. I could have made it 1.5 there. I could have left it as 3 over 2, but I was trying to make things easier on you. So I choose to leave it as 1/2, and the reason why is because this one is the 3/4. If I would have stuck that into a calculator and gotten 0.75, then I'd have left this as 0.5. Just so I could match, that's all. So right here, I can write my answer. 3 over 4, 1/2. If they write it as a decimal in the back of the book, it's fine. If they write it as a fraction in the back of the book, it's fine. As long as they're the same numbers, we're all good. Comfy? Ready for classwork and homework? I know that you are. Put it right here. Classwork. Numbers 1, 3, and 5. Homework. Numbers 7, 9, and 11. And they are on page 453. And the next time you see me, we'll go over the last way to do them.